and I need not to go in deep because you may be knowing how what are the system software's examples, that is the operating system, compilers, assemblers, loaders, and linkers. These are nothing but called as the system softwares, and even the device drivers, the softwares which are helping to have the device drivers, something like CD drivers, etc., floppy drivers were earlier, but nowadays the pen drive drivers are there. These are the softwares which are helping for the system, so I mean which are called as the system softwares. And the next part is about the application software, which we have to, which I have given you many more examples of the application softwares like MS Office, Adobe Photoshop, and also many other applications like Paint, Word, editors. These are called as the application softwares. And even I have this is the just brief, once again briefly I am telling you about what was the previous class. The system software works as the middleware between the application and the hardware, and this is how the we were only having a computer box is not enough. For that, operating system is required, and on top of that, we require even to function that operating system application softwares. And in that application software, the user needs are loaded. So we require the operating system, that is nothing but the operating system, which is nothing but the central heart of the any machine. So hardwares and softwares are required. All the softwares which are supporting for working of the applications or for working of the program. Operating system is called as a big program, and in that using the big program, we have other system softwares programs also, something like compilers, assemblers, loaders, linkers, etc. I think I'm going in a very one way. Please, if you want to say something, you can put it in a message box. I'm very sorry today again something disturbed. It has happened. So due to inconvenience of the audible. So maybe you're okay. Keep messaging me. I will just go through that. And if you have any doubt, even after the class, you can just call me back also. And now also you can put me in the message box. So I hope you're listening. So let me check here once again what is happened here with the mic of the speakers. Yes, they are correct working, but still why I don't respond? I don't get any audible voice from your side. Okay, I feel very happy that there are 63 students have been joined. I'm so happy. I'm so glad to have you all here in my class. So let us continue. What was the previous class which I have told you, and today's class will be all about the we'll be studying about the program generation and program execution. Program generation and program execution. So you are seeing the screen. So program generation and program execution. So I have told you about the semantic gap has many consequences, that is large development times, large development effort, and poor quality. Due to that, we need to develop the big softwares. So this is what the slide which I am showing you, the gap between the specification gap and the execution gap. So we require the applications to be in such a way that whatever the user needs should fulfill, and the programming languages whatever we are using, it should support for that, and the program should be ready for the execution. And for this, whenever any high level language is translated into the machine, so it reads in zeros and ones, and after that again it detranslates into higher level language. So this is how the example which I have given. So I have also told you about interpreter is also a processor which bridges the which bridges an execution gap without generating the machine language program. That means the execution gap vanishes here. So vanishes here totally. How the execution gap vanishes here? Because it takes the instruction. It takes one by one instruction of the programming language and go for execution and correct that error and come back and again take the another line for the execution. So the problem oriented languages, there are the three consequences of the semantic gaps are in fact the consequence of the specification gap. A classical solution is to develop in such a way that the programming language should be in such a way that the programming language domain is very close to identical to the application domain. Such PLs can only be used for specific applications. They are problem oriented languages. They are the problem oriented languages. So today's topic is program generation activities and the program execution activities. Fundamental activities divided into those that bridges the specification gap and the execution gap. So those, I mean, here once again let me tell you the clear idea. The program generation activities. A program generation activity aims at automatic generation of a program. Automatic generation of a program. Program generation activities aims at automatic generation of a program. So a source language is a specification language of a application domain, and that targets the language is procedure oriented language. The language is procedure oriented language. What are the main agendas of the program generation activities? The program generation activities, anyhow a program has to go for the execution. So before going the program for the execution, what a program has to be or how it has to be, the program, whatever the program is a source language, that source language itself is a specification language of the application domain, and the target language is the procedure oriented programming language. The program generator introduces a new domain between the application domain and application domain and programming language domain. Application domain and programming language domain. Call this program as the program generator. Now I hope you have come to know what is a program generator. Program generator is nothing but the program generator uses or introduces a new domain between the application and the programming language domain. Call this program as the program generator. It introduces a new domain between the application domain and the programming language domain. What are the programming languages? The programming languages are nothing but the C, C++, and Java, all low-level language and high-level language, whatever it is used. And between these two domains, that is application domain, between these two domains, it is application domain and program-oriented language domain. Between these two domains, a program is generated. That is generation of a program. From the generation of the program, once the specification is given or once the language itself makes us the specification for what we wanted the application, once the program is done, it goes for the execution. So in execution, we require the target language. The target language is nothing but something like a language which is generated from the machine language. Now you know very well what is a machine language. Machine language, it understands only in zeros and ones. Whatever may be the system software, either the compiler, assemblers, or it can be the interpreters, or it can be macros, So whatever may be, all these are called as the language processors, and these are nothing, they themselves are nothing but the translators. First, the compilers it uses, it makes the error corrections, then it gives for the assemblers for generation of the object code, that is nothing but the machine language, and then it gives for the I mean the machine language generates, and it gives for the linkers. Linker is also a program, big program or a big system software program. The linker generates the executable file. So that executable file, it generates various executable file, and that various executable file has to be fed or has to be loaded into the memory for execution of the program. So the linker, after linker, it goes with another translator, that is nothing but the loader. So loader loads the program into the memory. So that is how about the program generation activities. And specification gap now between the application domain and the program generation domain. Reduction in the specification gap increases the reliability of the generated gap. The point here is, in the specification gap between this, we need to go to such a type of programming language where there should be a proper reliability, in the program. So the program should be very fast. So in such a way, based on our application, the program be should make a choice of such a language, so that what it fits to the application. So for example, I'm doing some project on the rating app. So that rating app project or that rating app application should be done in what language? Should be done either in C, or should be done in C++, or should be done in Java. So what is the good language, so that I make the choice of that? So that the specification gap, we should resolve that. The specification gap we should resolve first, then it helps for the resolving the execution gap. It helps for the resolving the execution gap. And whatever the problem is oriented in this problem oriented language domain. So say for example, C++ is a very good language which helps in strong networking apps applications, whereas the rating app may require either the C hash or may require Java something like Java. So that is my application domain. So using that application domain for that language, what best it suits the programming language, so that it goes for the execution of the program. Here, in the specification of the program, now the arrangement reduces to the testing effort. In the specification of the program, if the program is having error, so every big program, every compiler has got its own capability of rectifying the errors. That itself is called as the compiler, or it may be having the interpreter. Well, both of them do the same job. Compiler takes all the source program at a time and goes for the error corrections and go for execution. Whereas the interpreter takes the line by line of the program or line by line code of the program, and one line just take for program correction, that is the error correction, that is nothing but the program generator, go for error checking, find some errors, again come back and again take the another line of a code and go for the program generator and do the generate the target language. Target programming language is nothing but the machine language. Target programming language is nothing but the machine language. In program execution, there are the two popular models, that is program translation and program interpretations. Program translation interpretation is nothing but how the language or how each line of the code is interpreted into the machine, is interpreted into the machine. So I hope you have messaged me in the chat box. Is there anybody who is having any doubts? Please can ask me your doubts, and I would like to show you the PDF also. Don't worry. Today I will mail you. You can drop me your mail IDs so that I can drop you the PDF file also. This is how once again I would like to show you the PDF file which I have documented. The specification gap is the semantic gap between the specification the program that performs the same task written in programming different programming language. And we have the language processors. The spectrum of the language processor is defined to meet practical requirements, is defined to meet the practical requirements. That is, the language translator is defined language processor. We are studying the language processor. The language processor the language processor, you know very well what is a language processor. In the since in the last class also I have told you the language processor is a software which bridges a specification or the execution gap. We use the term language processor to decide the activity performed by the language processor. Language processors are all the translators like compiler, assemblers, interpreters, linkers and loaders. These are nothing but the translators. Compilers, assemblers and interpreters are nothing but the language translators which convert the high level language into the machine language. So we use the term language processing to describe the activity performed by the language processor, and we refer the program in the form of the input for the language processor as the source program, and it gives us the target program. So the spectrum of the language processor is defined to meet the practical requirements, that is language translators. A language translator bridges an execution gap to the machine language or the assembly. It bridges an execution gap. It bridges what? An execution gap between the machine language of a computer. And I have told you in the previous class what is the machine language. Machine language is nothing but 0 and 1. 0 and 1. It's a language which is called as the low level. An assembler is a translator whose source language is assembly language. A compiler is any language translator which is not an assembler. A translator bridges the same execution gap as the language translator, but in the reverse direction. A processor is a language processor which bridges an execution gap, but in a reverse. That is what in the last class also I have told you about that. A processor is a language processor which bridges an execution gap but is not a language translator. But a preprocessor is not a language processor. Preprocessor is nothing but it takes the input for the compiler and it deals with the macro processing and file inclusions. So those are called as the preprocessors. Macro processors are also called as the preprocessors. It takes the input for the compiler, but preprocessors are not as the translators, are not called as the processor. Language migrator bridges the specification gap between two programming languages. between two programming languages. Following figure 3 is the program, that is how which I have shown you in the PPT language processor, which I have shown you in the PPT slide also. How is the language processor? That is the translator. This is how program translation. The program translation model bridges the execution gap by translating a source program into a program in the machine or assembly language of the computer system called as the target program. Called as the target program. So it is nothing but a source program as it takes any compiler. That compiler it rectifies the error. It just sort out the errors in a program. That itself is nothing but a translator, and it generates an target language. The target language is called as the machine language. The target language is called as the machine language. Program translation. The program translation model bridges the execution gap by translating a source program into program in the machine or assembly language of the program or assembly language of the computer system called as the target program. Characteristics of the program translation model. I have just given here the three characteristics. That is, the program must be translated before it can be executed. The translated program may be saved in a file, and the saved program may be executed repeatedly. The program must be translated following modification. The program must be translated for the following modifications. So that is how the characteristics. Once again, the characteristics I will tell you. The characteristics of the program translation. The translations are nothing but the something like compilers, assemblers are called as the translations, and even the linkers and loaders. These are called as the translations. They themselves have got the specific model. Like compiler gives you the a compiler takes the source program and generates you the machine language. After rectifying the errors, after clearing the errors, it generates an assembly language. The translated program may be saved in a file, and that translated program saved in the file, and the saved program may be repeatedly executed. The saved program may be repeatedly executed. The program must be translated following modifications. The program must be translated to the following modifications. So the program interpretations. During the interpretations, this is the next feature of the programming translation model. First, I have told you program translation, and the next is program interpretation. Program translation is translating from source program to some other model. What is that some other model? Which generates the target language, that is nothing but the machine language, and the executable, which is bridging the gap for the execution program or program execution generation. And program interpretation. During the program interpretation, interpreter takes the source program statement, determines its meaning, and performs action which implement it. It interprets, takes the source program statement and determines its meaning and performs the actions which implement it. The function of an interpreter is same as the execution of the machine language programmed by CPU. Programmed by CPU. So the function of the interpreter is same as the execution of the machine language programmed by CPU. So the function of the interpreter is same as the execution of the machine language, that is the program by CPU. I will tell you what are the different stages in the program execution. There are 3 cycles. Fetch the program, that is nothing but the load program, and be ready for execution. That I will show you the slide in the next slide. Here it is. Interpreter, it just rectifies the errors of the source program and load it into the memory that is the machine language loading to the memory, and the processing unit, that is the central processing unit. The central processing unit reads the machine language plus the data of what is given by the linker. So it takes the all the linker files, that is the executable files, and go for program executions. The characteristics here I'm just showing you here. The source program is retained in the source form itself. No target program form exits. A statement is analyzed during its interpretation. Comparison, that is, the comparison is done in the translator. Whole program is translated into the target. And if modified, the whole source program is translated, irrespective to size of modifications. That not the in case of interpretations is slower than execution of machine language program. That is true, as interpreter is same as the compiler, but interpreter is also a type of the target language, and it is nothing but the simplified code or the reduced code or optimized code. They are ready for executing the program. Interpreters, it optimizes the code. It optimizes the code and makes the program for execution. So that is the program for execution, and it gives to the memory, that is using the loader software, that is using the loader softwares. So here I have told you the characteristics. The source program The source program is retained in the source form itself, and no target program forms they exist. A statement is analyzed during its interpretation, that is optimized code, and comparison. In translator, whole program is translated into target program. And if modified, the whole source program is translated irrespective of size of modification. That not the in case of interpretation is slower than execution of machine language. So I have come to the fundamentals of the language processing. So once again, I will show you the PDF file what I have been taught in a point wise. You can see right from the beginning. I would like to show the beginning of the language processor is nothing but the introduction. In the introduction, we have seen the specification gap, that is the semantic gap between the application domain and the execution between the application domain and the execution domain. Why this semantic gap? Semantic gap is nothing but to generate the meaningful result, to generate the meaningful result. So this is the term semantic represents the rules of meaning of a domain, and the term semantic gap to represent the difference between the semantics of two domains. So that is what the semantics of two domains is: application and execution gap. If any doubt, let me check your chat box what you have posted. So is there any doubt? Yes. So these are the students who have been joined. So you people are no, hope you people are understanding. Yes, Mayuri, can you post me any doubt? Dipti Patil. Dipti Patil. Yes, Dipti Patil. Can you post me any doubt? Dipti Patil. Can you post me your doubt? No doubt. Okay, thank you. Are you understanding? Are you understanding? Just see the beginning. Somebody have posted me to show the PDF file. Some students. I am very happy to share you the PDF file also. So this is how your syllabus. Semantic gap has many consequences: large development effort times, and poor quality. And I have told you what is the system softwares is broadly divided into two classifications, that is applications and domain and application domain and system software. System software's examples are assemblers, loaders, linkers, and compilers. And applications, any app like editor, MS Office. All these are applications which fetches the requirements of the users, and the software engineers steps aimed to use the programming language that can be grouped into specification, design, and coding steps, and programming into implementations, and from the specification gap to execution gap, it bridges the application, whatever the application we require, it bridges the application from source language to execution. So what it bridges means translators, it bridges. The gap is to bridge by the software designer. Okay, so they make use of the languages. They make use of the programming languages. So that programming languages are used for specific designing the program and to meet the execution level. So here the spectrum of the language processors to meet the practical requirements, that is language translators we have, and also we have detranslated deep preprocessors. And the example is of the C++. C++ is itself is called as the preprocessor, and C++ is also called as the translators. Is also called as the translator. Why preprocessors here? Why? Because you see here the program one. The following example has the two language processors. That is has the two language processor, that is C++ preprocessor and translators and translators. The language processor of the part A converts the C++ program into C program. Hence, it is called as the preprocessor. Why it is called as preprocessor? Because I am giving you this here. The source program is C program, but where I have here the compiler as C++. That is what it is called as the preprocessor. And in the B example, the language processor in the B part is a language translator for C++, since it produces the machine language program. Since it produces the machine language program. Now, what is the difference between these two? Anyhow, the C++ language is used. Here also the C++ language is used. But in this C++ language, I have used a C code. So that is what at that instant I am calling it as a preprocessor. And here I am calling it as a translator. Why I am calling it as a translator? Because this C++ translator, now it is acting. Here also it was a processor. Here also it is a processor only. But in this compiler, in this big program, I have added a small C program, which is a lower version of the C++. That's what it is called as the preprocessor. And here it is in C++ translator. I am taking the source program and it is working accordingly the compiler to generate the machine language. And this generated machine language goes for which is nothing but the target language, goes for the executable file by linking and loading it into the memory. So that is what it is, the language processor. And all about interpreter also I have told you. The interpreter takes one by one code and go for the execution of the program. The programming language domain and execution language domain, it bridges the gap between the execution and it reduces the gap between the execution and application domain. Who are the problem oriented and procedure oriented? They are large consuming time and takes lot of effort, and they have very poor quality, like structures, like structures. So here I am showing you the which is the problem oriented language. Here the specification, here the specification gap is that application domain and problem oriented, which is nothing but structure based, like say for example structure oriented language, procedure oriented language, like we use structures. So those structures are called as the problem oriented languages. I mean such examples are called as the, and these here it is a specification gap, and after the specification gap it is bridging from the specification to the execution gap to have the executions, to have the executions. So here it is very closely related. Here we don't have, there is a large gap for the execution because it has to generate first the object code, that is nothing but the target language, and they are very poor quality type of the program. It takes a lot of time consuming it's not that much reliable to work with the structure based program. So that bridging of the gap, which is ready for the execution of the program, is making use of the, is by use of the higher versions of the language. So language processing activities are two types of language processing activities. The fundamental language processing activity can be divided into those that bridges the specification gap and those that bridges the execution gap. We name these activities as program generation activities. The program generation activity aims at automatic generation of the program, and the source language is the specification language of the application domain, and the target language is typically a procedure oriented language. The target language is typically a procedure oriented programming language. The target language is nothing but the machine language, and that machine language, whatever it is generated in the computer system or needs memory, that is called as the procedure oriented language. A program generation activity aims at automatic generation of the program. The source language is a specification language of the application of an application domain, and the target language is typically a procedure oriented. The program execution activities. Now here we have, as I said, two activities in the language processing activities. Language processing activities, program generation activity and program execution, which is fulfilling the, or which is reducing the gap between the application specification domain and execution. So program execution activities organizes the execution of a program written in any programming language of the computer system. Its source language could be procedure oriented language, procedure oriented language, or problem oriented language. So here let us see in program generation activity how the generation of the program, how the generation of the program generation activity depict, I mean the figure whatever is shown here, that is program generator. Take the big program, a compiler, and give the source program. Source program is nothing but specification of the program and depicts the program activity. The program generator is a software system which accepts the specification of a program to be generated and generates a program in the target. So the generator introduces a new domain called the program generator domain between the application and programming language domain, which is as shown in this figure. Okay, in the below figure 8 depicts the program generation activity. This is how the program generation activity. The program generator is a software system which accepts the specification of the program, which accepts the specification of the program, which accepts the specification of the program to be generated and generates a program in the target which accepts the specification of the program and generates the program in the target programming language. So the program generator introduces a new domain called the program generator domain between the application and programming language domain, which is as shown in the figure 8, which is as shown in the figure 8. Let me show you that figure. So the figure 8, this is the application domain and this is the program generator. The program generator generates up to target language. So the programming language domain, whatever the languages we have, those languages they themselves are ready for execution of the program. They themselves are ready for the execution of the program. So that is what here we are not taking any bridging the gap, any gap which is bridging them. So here they are programs. They themselves are separate programs. So in that programs we combine the model, and like say for example C program or C software, it itself is a big program, and the programming language in that the C language is nothing but the specification to that processor, to that compiler or the processor, and that compiler or the processor, it itself will have the adhere capacity of different translators, that is the compilers, compilers, assemblers, linkers and loaders. So here that's what the gap is not at being, here the nothing gap is bridging between them. So that figure, whatever this figure is being translated like this, why the gap is not bridging, why that gap is not bridging from specification domain to execution domain. The specification gap is now the gap between the application domain and the program generator domain. This gap is smaller than the gap between the application domain and the target, because the language what we made choice, so that itself is making here the reduction of the specification gap. So here it increases the reliability of the generated program. That's what we are going for, the higher versions of the language. The harder task of the bridging the gap to the programming language is performed by the generator. It's performed by the generator. Now let me tell you one more example. A screen handling program handles the screen I/O in a data entry environment. It displays the field handling. It displays the field heading and default values. Say for example, you are filling some form. So assume that you are filling some form here. Employee name, address, and status of the marital, and also the age and gender, So here this is an application which I wanted. For this application, what is the best suit to adopt the programming language? That itself, these are called as the, assume that what are the programming activities here? The programming activities here are nothing but the specification of the language, and that's in that specification how we make the choice of using which language, either C or C++ or Java. So this is my application domain. For this application domain, once I submit the form, that is nothing but the execution part. That is nothing but the execution is generated, or program generation activity and execution execution handling, or program execution handling up to there. So here once I submit this form, so before this, how the specification should be should be, or how you write or how you do the coding. Something here like employee name, which is the label to be displayed on the screen, and marital status is also which is the label to be displayed on. These are the specifications for having the employee name, for having the employee name. Something like at the start line, at the position 2, and position I'm giving of 25, and I'm ending at the line 2 and with the position of 80. Like say for example, how much should be the width, how much should be the width of this label called as employee, because your name, first name, middle name and last name, so this much is the width. To fulfill this much width, I'm just specifying in the label itself only what should be the length, or what should be the specification after the employee name. The specification here, the gap between this is of how much, maybe is of, the gap between this is at the 25 to 80 line when once you see on the screen. And for the address also the same, assume that I have given some specification what should be the address. The address can be of again multiple lines, because address cannot be fulfilled, because where you are saying which city, what is the line, or what is the road. So these are the different addresses, not different addresses of the same, but it takes the multiple line. So marital status, it is only in yes or no, so it can be as the something like the combo box. It can be something like combo box. Whereas the another field which I have added here as age and gender. So for age and gender, once I submit this, that is nothing but the execution part, the model which is going for the execution model. Here the errors can be in the specification invalid, also the start or end positions conflicting the specifications. For the field also it can arise, and are detected by the program generator. These are detected by the program generated, and the generated screen handling program validates the data during the entry. Like age field must be the must only contain the digit, and even the gender must have only F or M. F or M. That is how the example of the specification language to the execution language. And in program execution, the translation and interpretation is required. The two popular models, that is the translation and interpretations. The translation and interpretations, as I have shown in the PPT also. The translation and interpreters. Here we have seen the translations and interpretations. Program translation and interpretations. So in the program translation and interpretations, the program translation is nothing but the source program. It takes the source program by translating the program written in the so-called language. So here I'm just showing you the figure, the program translation model. This is the translators. It can be C++ or Java or any high level language, and these are the data stored for those translated data, which are interpreted data, and those are ready for the execution. Those are ready for the sorry, not for the execution, to generate the machine language. And the machine language generated itself is called as the target program. The program translation model bridges the execution gap by translating a program programming language written in language called as the source program. So called as the source program and called as the source program into an equivalent program in the machine or assembly language of the computer called as the target program. So here you might have understood what is the program translation. Program translation model bridges the execution gap by translating the program written in programming language called as the source program into an equivalent program in the machine or assembly language of the computer system called as the target program. Called as the target program. So let me check anything. What you have given in the message box? Any doubts? Prashant? Prashant, any doubt? Vivek? Pratik Yadav? Pratik Yadav? Pranali? Pranali? Pooja?
Yes, ma'am.
Pooja? Aishwarya? Any doubts? You can post me. Yes, are you understanding? Are you understanding, Prashant? Prashant, can you share me your doubts?
Yes, ma'am.
Yes, Prashant. Can you share me your doubts?
Hello, ma'am.
Hello. Prashant, hold out. Okay. Shall I send you the PDF for you? To all, I will send you. Can you post me your mail IDs of your class? Full class. Can I share you the PDF? I have done very neatly the PDF point wise. Okay. I can see here, yes, you're telling. Okay, I will share you the PDF also. Today I have shared the PDF to one of your friend, one of your classmate. Okay, I will continue. Still, I have some more half an hour to continue. Thanks. I will note it down, this PDF. Okay. And I will share you this, I mean, whatever is required. Okay. I'll copy this, your address link, whatever you have given. It's going good or not? How the class? Yes. Prashant, you're understanding. Okay, okay. Good, ma'am. You're telling. Okay, thank you, man. But still, it should have been very interactive session. But somebody has muted. I don't know what happened. But this is the next second time I will check next time also what you are doing. Okay. Thank you, man. Shall I keep going? Shall I keep going? Shall I go to the next topic? Please text me. Okay. I'll go to the next topic. These are the program translation. Well, it's all about the theory only. You need to understand. Okay, what the program is translating. Translators are C and C++. Here the translator. So you know very well that C itself is a compiler. It removes the error. It identifies the error because it is having lexical analysis, and it is having the scanner. It does the scanner, and therefore it is having that capacity to identify the errors if any comma, if any semicolon is missing, and that is given for assembler does, and whatever the data is available, assembler does the machine language, in the sense it translates into the machine language. That is what the program translation, and this happens based on the language what we made choice. So the characteristics of the program translation model, a program must be, the characteristics of the program translation model must be translated before it can be executed. The translated program may be saved in a file. The saved program may be executed repeatedly, and the program must be translated in the following modifications, like the following modification. The CPU uses the program counter as the CPU. You may be knowing the computer organization. As I told in the prerequisite, you must use the some part of the prerequisite also, of before going into the system programming. In prerequisite, I have told you what you require. You require data structure knowledge, you require computer organization knowledge, also you require the knowledge of programming languages, and all these programming languages are nothing but they themselves are a big program. Take example of any programming language like C. C itself is a big program. I can tell as C is a system software. Of course, C is called as a programming language, but let us see. Now, what happens in that? See, every language, they themselves build a machine, huge machine, big machine. They themselves build a huge machine. That is nothing but the system software. If I write some language, for my language, I should write the activities, that is processing activities, that is translators. That is, if I want to translate some code, some my verbal word into your understanding language, that means I want some translators. So for that translators, I require I require something like I require something like the machines, something like its own system softwares. There's its own system software, something like compiler and its interpreter. Like C itself is called as a compiler, and C++ is also called as a compiler. It itself, like you might have heard the words like Borland, and you might have heard the words like Turbo C, compiler. So these are nothing but their own. I mean, every language have got their own compilers. So here the funda of the system software is nothing but to understand about the compiler machine. And this compiler machine, how a program is generated. How a program is generated means the program generated is nothing but how a program is ready for execution. Now, I said there are different translators: compilers, assemblers, linkers, and loaders. Compiler, it will take a source program. Compiler, it will take a source program and translate. Compiler, now it itself become as a translators, because compiler takes the source program of the C, assume that C program of the source, and gives and act as a translator and gives for assemblers for generating the machine language, and this machine language itself is called as the target language. This itself is called as the target language, and this happens at the application level of the programmer designing. Okay, now further in a system, in a computer system, what happens means it takes this assembly language or the target language. This takes its target language and it generates different, it does the mapping with the different executable files. Mapping in the sense it goes for linking, because further this assembler act as a translator. Further this assembler act as a translator. How does it act as a translator means? How does it act as a translator means? Because it is giving, it is making a link, or it is transferring its whatever generated target language to the linker, to the next phase. So the next phase, what it is doing, it is linking. What it is doing? It is linking. During this period, linking period, what does it have? Linker. During this linker or linking period, whatever the file, like so for example in your program you have something like square root, so you are using a square root function. So this square root function is or some trigonometric function, so these functions are related with math.h, so it has to generate its own executable file, so it should make a proper matching. Oh, this square root function is related to my library function, so sorry, related to my inclusion of the library. So it finds various such a matching in the program and makes as executor. So it links the various executable files of a program and makes it ready for the execution of the program. So it gives now the linker generates, or linker now acts as a translator and generates the exe file, dot exe file. So this dot exe file is generated. This dot.exe file, what it does, it is again given to the memory. That is what loader. So because of that, we have here three phases. So the CPU uses the program counter, the addresses of the next instruction to be executed. So this part is done by the execution part, and this part is done by the software called as system software called as loader. It is loading the executable file into the memory. It is loading the executable file into the memory. The CPU uses the program counter because it is checking for the next instruction what it has to be done. What it has to be done. The program counter to note the address of the next instruction to be executed. And this instruction is subjected to the instruction execution cycle consisting of the following steps. So this part happens where? This part happens in a execution, program execution, not the program generation. Program generation is over up to the program generation up to where specification of the language to the programming language, specification of the language to the programming language, that is up to using the compiler, assemblers and linkers. Now this is what the software which is done using the loaders. Now actually loader is ready to take, loader itself again acts as a translator. It is ready to take the executable file which is generated by the linker, and this linker, it takes the file from the assembler, that is obj file, means object file or target file, object file or target file. And this object file or target file, it is taken from the assembler, and from assembler, what is the input it is coming? The source file from the compiler to assembler, assembler to linker, linker to loader. Now this part is explained, or this part is of the loader part. What is happening in the memory? Now I have written the program, assume that errors are cleared, that, and it is ready to execute now. So during that period, what it does, it fetches the instructions. So for example, in my program, I have so many arithmetic operations. So I'm using something like plus a plus b. The result is stored in something like C. So I'm using something like, or I'm doing some program on addition, subtraction, or some, or all the four operators I'm doing in one program, like addition, subtraction, multiplication, and division. So all this program, how does it does the fetching of the instructions? Addition. Usually, if I use the low level language like assemblers, it takes the mnemonic language, or it takes the mnemonic word add. Add sub mul has got their own codes, machine code. Add is 01, subtraction is sub is 02, and multiplication is 03, load is 00, store is 01, something like this. So they have their own machine coded language. So it fetches all the instructions in the program, and it decodes the instruction to determine what operation to be performed, whether plus, multiply, whatever is used in the program, and also its operand. Means it fetches the operand's address where it has to be loaded, the computer result, like say for example a plus C, where it has to be loaded, and in the memory. So they execute the instruction. So now it is ready to execute the instruction. So this cycle it does for all of the instructions, for all of the line of the code in the program. And this task is repeated. These three tasks are repeated. So that is what here the program counter is used, because in the previous line where the program counter, where the memory location is there, that memory location, if it gets any interrupts in between, so it stops there only, go for the performing of the other work and come back and do the where it has left. Therefore the program counter is used in noting down where the pointer is, or where in a program the program location is going on of the instructions. Like say for example, first instruction is add, next instruction may be some multiplication. So this is made using, because the program counter points to the next instructions, points to the next instruction, and the program interpretations can proceed in a analogous manner. Thus, the program counter can indicate which statement of the source program is to be interpreted next. This statement would be subjected to the interpretation cycle, and which would consist of the following step. Again, fetch the statement, analyze the statement of the I think you have studied in computer organization this part of the execution phase. So, fetch the statement, analyze the statement, and determine its meaning, the computation to be performed, and its operand, execute the meaning of the statement. So here, interpret, the program counter takes the line of the code and from the source program, because the source program already we save it as something by xyz, assume that, so it is in the memory. And the program counter, what the program counter does, the program counter takes line by line instruction of the program, and those line by line generated of the program. I mean here the machine language which is generated by the assemblers, they go to the memory. They go using the loaders. They go to the memory for program execution. I think that in the loggers in computer organization, and for this we identify the following characteristics. The source program is retained in the source form itself. That is, no target program form exists. A statement is analyzed during its interpretation. So what the comparison? Fixed cost, the comparison we can see here. Translation overhead is there. The translation overhead is there and is incurred in the use of program translation model, means it is included in the program translation model, because see here, during the load time and during the fetch and load, these are the fetch is nothing but the input, load is nothing but getting into the memory, something is going into the memory. Fetch and load, they take the more translation, same type of translation. Assume that during the fetch is there during the fetch is during interpretation time, and load is loading into the memory. This is from the for the execution of the program. So if a program is having any error, it may clear rectifies the errors of the source program. So after clearing the errors of the source program, now it is ready. Now it is ready to go to the memory and execute the program. The comparison of both the figures, the fixed translation overhead is incurred in the use of the program translation model. If the source program is modified, the translation cost must be incurred again irrespective of the size of the modification. However, the execution of the target program is efficient since the target program is in the machine language. Use of the interpretation model does not incur the translation overheads, and this is dangerous if the program is modified between the execution, and this is dangerous if the program is modified between the execution. As a program testing and debugging, interpretation is slower than the execution of the machine language program because of the step 2. So interpretation cycle takes time. So now let me move on to the fundamentals of language processing. As I said, the fundamentals of the language processing is the specification and the target of the program. So it consists of the three components, that is lexical rules, syntax rules, and semantic rules. Lexical rules, syntax, and semantic rules. So in the PPT slide, let me show you today's the next feature, that is the fundamentals of the language processing. The language processing is equal to analysis of the source program and synthesis of the target program. Synthesis of the target program. The language processing is equal to, how is the language processing? We have studied the processors. Now how the language processing? Say for example, I have int a comma b comma c. So this code or this line of code, how does it processes? How does it processes? Analysis of source program, synthesis of target program. Analysis of source program is nothing but feeding into the compiler. The source program is fed into the compiler. Compiler generates what? Or it acts as a translator and gives to the assembler. Assembler generates what? It synthesizes according to its processing step and generates the machine language or the target program. The analysis phase of the processing has again got how many? I cannot complete the word in saying yes. It is given to the compiler. A source program is given to the compiler. During this period, what the processing steps of the languages it happens. Something we have the three components, that is lexical rules, syntax rules, and semantic. Lexical, which governs the formation of valued lexical units in the source language. Of the source language. Then syntax rule, which governs the formation of the valid statements in the source language. The semantic rule, which associates meaning with the valid statement of the language. Lexical rule, which governs the formation of the valid lexical units in the source language. Like say for example, int a comma b comma c. Like how say for example, I will show you. Int a comma b comma c. Int int a comma b comma c, and after this I have given semicolon, but int is capital here. Int is capital. So the lexical analysis, what it does, it see its language. Actually any language, if we are adopting either C or C++, see what is its language syntax. What is its language syntax? It never, if it is a case sensitive, because every language has got its own format, syntactical rules. So it should see, it should check the syntaxical. So here small I is required, int, and also gap is required, int a comma b comma c. If anything is missing from this syntax, so what is the syntax rule? Any language should follow the syntax rule. The syntax rule is data type, then space, then variables. How is the syntax rule? Variables, list of. This is how the syntax, and terminate using the semicolon. If you have many more variables, all variables, variable 1, variable 2, so it should be separated by comma. So it should be separated by comma. This is one example. Every language has got its own format of how should be a language. So then only it rectifies the error, or then only it adds accordingly these three components. What are these three components? The three components which I have shown here. Any language should have its own rule. So its own rule, how it will be? Language analysis, lexical rule, syntax rule, semantic rule. Lexical rule, which governs the formation of whether it's a valid or invalid source language, like that. So for example, instead of int, I may be using number. So whether int and number is a valid or not. So first of all, number is not a valid in C language. So I must use saying as int. So that is nothing but the lexical rule. And syntax rule, which governs the formation of the valid statement in the source language. Which governs the valid statement. After following the rule of the lexical, now the syntax, whether first of all the words or the dictionaries which is used in the lexical rules belongs to that particular compiler, or belongs to that particular program, or belongs to that particular language or not. It will identify that. Like say for example, your names are not identifiable by C language. Assume that if I have a system like C and I am following its language, and I want to type something like your name, and in a source program it doesn't identify your name. So that name it does not know, because it is not in its dictionary. Suppose, say for example, something like void, main, if, else, these are in its dictionary. It identifies its own words, or it identifies its own basic building blocks. Okay. Next is syntax rule. Syntax rules, which governs the formation of the whether the statement is valid or not, and semantic, which generates the meaning with the valid. So for example, here which I am showing, So for this example, and for this example, int a comma b comma c. This int a comma b comma c are the three variables, list of three variables. First of all, int belongs to C language. Int belongs to C language, that is lexical, which governs. Suppose instead of int, if I give num, because I want to quote A, B, C as number. So where num is not identified in C, therefore int is identified in C. And what the lexical analysis does, what the lexical analysis does means, sorry, lexically, which governs the whether that words belong to his or not, and syntax rule, which governs the formation of the valid statement in the source language, which governs the valid statement in the source language. Valid statement, how it can be? The statement, how it can be valid? Yes, this is the valid. And if I quote another example, say for example, int a something like dot and something like b, I have done. So this is not a valid. This is what it does in syntax. This is not, because syntax, every variable should be separated by comma. So which governs the syntax. This is not the syntax. Now next point, what it is? Next point is semantic rule. Semantic rule means it goes to the next. First of all it should be something like this is means obeyable. They should be agreeable. Yes, int belongs to, that is the first rule. What is the first rule? Lexical rule. The first rule is lexical rule, syntax rule, and semantic rule. Yes, the first rule, first of all, it belongs to the first rule. So all these rules, when they are satisfied, then only it processes the code, or then only it processes the language. Yes, first of all, the int belongs to the language. Next, that is what the lexical, and next it follows the syntax. This particular statement follows the syntax. The syntax is data type and list of variables. Data type and list of variables. Second rule is also agreed, and the third rule is nothing but it should generate a semantic, means it should generate a proper meaning. The meaning of this code is that the meaning of this code is that where a comma b comma b comma c are nothing but the three variables or three operands, and these three operands are utilized for integer. These three operands are utilized for integers. That means these three operands are nothing but the integer data types, not the floating value. And these three operands are now listed into the memory location. Are now listed in, that is what the fetch. That is what the fetch are listed into the memory. That is what the fetch. So that is the semantic rule. Semantic rule means which generates the proper meaning. The meaning of this statement is that first of all it is a data type int, and this meaning of this sentence or this code, the meaning of this code is nothing but it generates the three variables a, b, c, and they are of numbers, that is integers, not the floating values. If you give floating value, it truncate accordingly.
Hello, ma'am.
Truncate and take only the integer part. Truncate and take only the integer part. Yes, are you listening? Aparna? Aparna, are you there?
Yes, ma'am.
Can I see the chat box? Yes, can I see the chat box? Any doubts? Any doubt? Any doubt? Aparna? Aparna, any doubt? Bhakti? Bhakti, any doubt? Anisha? 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 Bhakti came. Bhakti was left, na? Are you understanding? The subject is bit complex, right? But the main funda I have told you. System software means assemblers, compilers, loaders, linkers. This is a system software. Somewhat getting, ma'am, but it takes time to understand. Of course. Okay, okay, no problem. It takes time to understand, yes. Because if there should be a chalk and board, how the compiler does, what the assembler does. Here I am going according to the syllabus. Somebody have posted me that saying that you wanted PDF. Somebody have posted me saying as PDF. So I have come up with PDF also and even the PPT slide also, and I have shared with one of your friend also. Okay, I've shared with one of your friend also, and this is what the source program it takes by the assembly, and this synthesizes has got its three phases. See, any language simply you cannot execute. It goes in its internal processing states. It goes into its internal processing states. So those internal processing states are nothing but lexical analysis, lexical analysis, syntax analysis, semantic analysis. Means checking for the syntax and go for generation of the executable code. Okay, generate a proper, and still furthermore steps are there for processing of those object language to the executable code. That is what all are linked with each other. Okay. Anisha Sawant, any boys are there? Any boys? Shruti, Anisa. Okay, let me take the attendance. To take your attendance, I will just whatever you have posted here, I'll just copy paste in my list. Okay. If anybody is there, let them join. I'm taking the attendance. Ask your friends to join. Okay, because it's echo. Somebody have muted mine. Next time I will not give any permission like this. I'll just check all the availability. Okay. Somebody have muted you all. I'll check all those. No problem. How was the lecture? Vishwanath? I'll copy all this chat box. Okay, anyhow, it's in recording. So I will make note of these, whatever the posted are there. The last part of the syllabus, I will tell today's lecture. Lexical rule, which governs the formation of the valid units in the source language, and syntax rule, which governs the formation of the valid statement in the source language, and the semantic rule, which associates the meaning, which generates the meaning, Okay, let me copy yours, the chats. I will copy first. Okay, I have noted the attendances. Anybody who wish to join, don't leave the class till 12:15. Sorry, 1:15. Still 10 more minutes are there. Okay, I will tell Prashant. Repeat the rule once again. Okay, I will repeat the rule. Next lecture for our understanding. The rules, yeah. I will repeat. Now itself, still 10 minutes is there. See, language processing, the fundamentals of language processing. The language processing is being divided again into two. We should understand the language processing in two phases. That is specification and target programming. Okay, that is how which I have done here in slides also. In slides, I have shown you that the processing language is equal to source program and synthesis of target program. Source program. What is happening here means still we are in source program only. Language processing is equal to analysis of source program and synthesis of the target program. Here target program is nothing but the target program which is generated from the assembler, As I told you, as I told you, computer language is 0 and 1. So those 0 and 1 are generated by the assemblers. In a computer or in any machine, assemblers are there to convert the high level language to machine language. Okay, it converts into zeros and ones. Every machine. This happens with all type of the computer. So that phase we call it as the target phase. Means whatever the codes are generated by that, we call it as the target target phase. Before going to the target phase, anyhow we have our source program. That source program is fed into the compiler. That compiler can be your C, that compiler can be your C++, that compiler can be your Java. So every compiler have got, or every language, they themselves have got their own compiler. See, if I'm going to develop a C language, I should develop a compiler for it to understand the language, to understand the language. Or if I want to develop a Java language, or if I want to develop a Marathi language, I have to develop the Marathi compiler so that it understands the text of the Marathis. So during that period, we call it as analysis of the source program. The analysis of the source program, again it has got three components. The analysis of the source program, again it has got three components. That is syntax rule, semantic rules. Sorry, lexical syntax and semantic rule. The lexical rule which makes the statement as, like say for example in Marathi, काय झाले. काय झाले belongs to Marathi. Or is there any language, say for example, what are you doing? What, word called as what, are you, you, doing, dying. Does it belong to Marathi? You'll tell no, this does not belong to Marathi language. So it belongs to some English like language. So to understand their own specifications of the language, they themselves have the compilers. They themselves have the compilers. To understand their own specifications of the language, they themselves have the compilers. So every compiler passes through the two phases, that is specification of the programming and or specification of that processor and synthesis of that target program, because every compiler converts into machine code. That machine code is nothing but 0 and 1, and that is nothing but target. That is nothing but target phase. That is nothing but what? Target program. Here you see, that is nothing but the target program. Source program plus target program. Source program is the one, like say for example your own language Marathi is the source program, and for that Marathi, whatever the translated translations are done by the computer machine, that is called as the target program. And there only the job does not over. There only the job. Target program is an internal program again. Again, it is an internal process of a machine. Target program is again an internal process of a machine. Again, it has to revert back to the user. Like Kai Jhala means you should look like Kai Jhala only, the word on the screen. Okay. The word on the screen again it should look like Kai Jhala only. So that is nothing but again converting back to high level language. Your own language. That is again converting back to your own language. So the analysis phase of the language processing is lexical rule, syntax rule, semantic rule. 3. The analysis phase passes through the 3 phases. It's a big story actually, but still here I have made you very descriptive way. Lexical rule, so the example which I have used here, lexical rule, what it does, it identifies its language, like int, void, float, main, these are in C language. Like say for example, instead of int, if I take number, num, num does not belong to C. It's not found in its dictionary. So that is called as lexical. That is called as, first it identifies who are my words. First it identifies as who are my words. So which governs the formation of the valid lexical units in the source language. And syntax rules, which governs the formation of the valid statement. Which governs the formation of the valid statement. That is called as the syntax rule. Now the syntax rule, now to have some numbers in a C language, how you will have some numbers? First of all, you should have specification of that number, whether you wanted number to be an integer or whether you wanted the number to be a float. If you want the number to be a float, you should make it as float. If you want the number to be an integer, so you should make it as integer. This is nothing but whether, what type you wanted. So that is what the syntax. After lexical, syntax. The syntax after lexical, the syntax says data type and value. Like this, for all different lines of the program, for all different like there you come across so many situations, like if else statements are used, some decisions are made, some looping statements are made. To do all such things, language supports you logic their own logic and their own programming style. That is the syntax. Their own logic, their own style. That is what the syntax. So the syntax is nothing but syntactical analysis. Syntax is nothing but whether any code is in proper syntax or not. That is called a syntactical analysis. Semantic means for every syntax generated, it generates a proper meaning. Now it generates here a meaning like A, B, C are the integer types. If I write somewhere in the program A belongs to integer. And during the runtime, if I give the value for A as 5, it will take. But if I give the value as 5.12, it will truncate 1 2 after a decimal because A was already declared as integer. So in that way it generates the meaning. Understood? In that way it generates the meaning. Now here one example. Consider the cost, the language processors. It identifies the star as multiplication and the division sign as the operators, 100 as the constant remaining, and these are identified as lexical. See, observe here, these are identified as lexical analysis. Lexical analysis, what it identifies? Equal to, comma, star, and the division sign. All these operators are identified, and also it is identified as the 100, that as the constant, and the remaining as strings. And syntax is identified as the statement as the assignment statement with the percentage profit as the left hand side and the profit into 100 divided by cost price as the expression on the right hand side. And in semantic analysis, it determines the meaning of this expression. It determines the meaning of this expression, that it should be multiplied, the profit should be multiplied by 100 and should be divided by cost price. So all these are operands and they belong to that particular. And so synthesis phase is concerned with the construction of the target language. So after this, it does with the target language, which have the same meaning of the source statement typically. This consists of the two activities, that is creation of the data structure and generation of the target code. As I told, it won't stop here only. It goes into the memory. So for this, we need again the data structure, that is something like memory is required, that is some tables are required, symbol table, to manage all this to go into the memory. Here I have an example, that is mover. This is an example belong to assembly language. The following example is of assembly language, and you all are familiar with the assembly language. So move the profit into the argument areg. This is another parameter of profit is moved here and multiplied this argument with 100 and divide the cost price by cost price and move it into the percentage profit, whatever the computed value. And this is how it's stored in the memory. Percentage profit with data word of 1 and profit. This is how the declaration as I have shown using the C language. The phases and the passes of the language processor. The source program is processed into analysis phase and synthesis phase. Synthesis phase to generate the target program. Analysis phase, it passes with all the three types, that is lexical, syntactical, and semantical. And here the forward reference is the program entity, is a reference entity to the program. Here I would like to stop, and in the next we will study many more examples. And toy compiler, we will be going with them, another example of the toy compiler. Thank you one and all.